Alright, now we have number 13 for the exam 2 corrections. So, this says, evaluate the following limits using L'Hopital's rule. Be sure to identify the indeterminate forms. So for letter A, is the limit of x going to infinity of the natural log of 8x over 4x minus 5. Now this is going to be infinity over infinity if you just direct substitute infinity for x. So we have to L'Hopital rule. So we take the derivative of the top and the bottom separately, no quotient rule. So this will bring you to 1 over 8x times 8 because we have to chain rule this. So you take the inside and then multiply by the outside, all that. Then the bottom, or the denominator, is just simply 4. Drop the x, 5 goes away. Now this can simplify. The 4 turns the 8's into 2's, so it gives us 1 over 2x times 2. Now we can direct substitute, because the infinity basically eats all the numbers on the bottom. So it becomes 1 over infinity, which would be 0, because you can never get exact, it's going towards 0. So gotta be 1 over 0, or just 0, excuse me. Now for B, we have the limit of x going to 0 of 4e to the x minus x squared minus 4x minus 4 all over 4x to the fourth plus x squared. Now again, if you just direct substitute, this will be 0 over 0. So you can't L'Hopital, or you can't just go with that, you gotta L'Hopital. Now, the derivative for this one will is 4e to the x, because again, e to the x is always its own derivative. The x squared becomes 2x, 4x becomes 4, and the 4 just drops. Then on the bottom, 4x quad becomes 8x cubed, and the x squared becomes 2x. Again, if you direct substitute here, you're going to end up with the same answer. Can't do that. And that is shown here. Going to end up 0 over 0. That's a no-go. So we L'Hopital rule again. This brings us to 4e to the x minus 2. The 4 dropped off. 2x became just 2. Then the bottom is 24x squared plus 2. And then we can finally direct substitute, plug in 0 for everything. For this, the e to the 0 becomes 1. 4 times 1 minus 2. The 24x becomes 0 plus 2. 4 minus 2 over 2. 2 over 2. Your limit's 1. Now for C. For C, it is a little bit more complicated, because if you just direct substitute, since there's an infinity here and also an infinity as an exponent, it's just going to be 1 to infinity, so that's also a no-go. You have to L'Hopital. So for this one, since we want to bring this x down so we don't have that 1 to infinity problem, you have to take the natural log of it. So we take the natural log, bring the x down. Now we can finally get into derivative work and trying to make sense of this. So the derivative of natural log is 1 over x. So since you kind of have to product rule this, it's naturally going to be the natural log of 1 plus 10 over x over 1 over x. So then you also can't just plug in here, because since it's infinity, this is going to give you infinity over infinity. That's also a no-go. So this means that we come down here to this part. We take the derivative again. So it's kind of hard to see here, but it's going to give you 1 over 1 plus 10 over x times negative 10 over x squared over negative 1 over x squared. So here we can do a little bit of canceling out to make our life easier. So the x squares cancel out, the 10 goes on top, so that means we just have this 1 down here. So we're just left with the 10 over, and since the negatives cancel out as well, we're left with the positive again. So this leaves us with 10 over 1 plus 10 over x. Now we can direct substitute since there's only an x on the bottom. So we plug in our infinity here. 10 over infinity, that's going to be 0. So it'd be 10 over 1 plus 0, which is 10. And since we finally have a number, we plug that on top of our e, so our limit is e to the 10th.